We are now moving to the keynote address, as well as this is also the inaugural as well as the keynote address by our chief guest, Mr. M.V. Satish. I will take just a minute to give a bit of more details on Mr. M.V. Satish, a bit of about what he has done. He's actually the whole-time director and a senior executive vice president of Larsen and Toubro. He's currently responsible for the buildings and factories vertical within L&T. So Larsen and Toubro has many verticals. He's responsible for the building and factories vertical. He's a civil engineer. He started his career with L&T, worked in several roles in Larsen and Toubro, from engineering to business development. So he's had many hats in L&T, and we have worked quite closely with Mr. Satish and his team, and we have seen all the kind of good things that they do in bringing technology to construction. He's also played a very vital role in establishing L&T in the Gulf region, especially in Oman. So he's been instrumental in kind of setting up businesses for in construction for L&T in Oman. He's worked on airports, stadiums, hospitals, a wide range of projects. He's driving the design build and the EPC programs in L&T. Also, from a technology perspective, construction technologies such as precast and digital. I think we've had the opportunity recently to interact with Mr. Satish on 3D printing, and he's been championing this throughout. And if India has to see 3D printing kind of more volumes of it, it would be through L&T and through Mr. Satish's initiatives. With that, I would invite Mr. Satish to give us his lecture and keynote. He will be joined by Amit Bade, his colleague, to continue. So this is a 45-minute session. I think it's about 30 minutes of lecture and about 15 minutes of question and answers. Mr. Satish, I think, shall we move this? You have a presentation.
Hi, very good morning. Professor Kim, Professor Kamakoti, Professor Koshi, Professor Benny, all the experts in automation and robotics, the academia, the students, and a lot of my colleagues are here. I brought the largest contingent to make sure that we really implement this automation and robotics. Yeah. Just to tell about our relationship with IIT Madras. So we have been working with IIT Madras for a long time. It is actually for decades that we have been working. Most of our design, the vetting is always done by IIT Madras. Even the 3D printing, actually, our design. So we actually got the approval from BMTPC, which is the authority for approving the latest designs and all. So we actually collaborated with IIT Madras and we got it approved. Because otherwise, we can't construct 3D buildings. And see the technology, I think the only thing which is changing is technology. That's what we say in L&T. And technology drives everything. And we can see, I relate construction to manufacturing. And if you see in manufacturing, actually, a lot of, automation and robotics has come even in India. The other day I was talking to the CEO of actually JCB. And he says in India, every 3.29 minutes, a JCB goes up. But somewhere, the same, we build our factories. The JCB factories are built by us. But we are not being able to bring this kind of speed in any of our construction. And okay, I will show you that we have taken some baby steps. I would just call it baby steps that we have taken up in construction, how to automate in construction, design, monitoring and all. And we'll tell you. This is how actually the building was when we did. This is actually the Baha'i House of Worship in Delhi. This is the kind of farm work. This is in 1986. This photo is in 1986, where we use everything was timber. And we had actually 1,000 carpenters. In Delhi, all the carpenters were available in Delhi. We just took them. And this is the kind of construction that we are doing. Suppose you do a similar building now, maybe I think we'll do the whole thing with precast or something. The one, in Bangalore, the Kantirava Stadium that we have built, actually is completely precast. Probably, you could have used the precast there and it would have been much faster. This almost took 6 years, but only one thing, it is all white cement concrete, no touching, nothing. And we are not allowed to do any welding for the reinforcement. All actually, the stainless steel reinforcement, those days, it was all something new actually in those days. Coming to construction, first of all, I want to tell something about Mr. Benny said that, construction and all pays less. No, because I have so many IT students here. We pay much better than the IT industry. Okay. An IT industry, the trainees are taken, most of them get paid 2.5 lakhs. At least I pay 4 times that money. And only yesterday, 2,900 people, the trainees that we take from all the institutes are joined. But unfortunately, there are only 3 people from my age. The rest are from NIT, the other colleges and all. But still, so I would like to say that, I'll show how interesting it is actually, because, I call this the real original hardware of the world. So we do buildings, so this is a real original hardware. Coming to now, why we need the construction. Yesterday, actually, I was shouting at my people. I went to 3 places. I went to Bhubaneswar. Actually, that building is completely steel building. It's a hospital, a 3,300 bed hospital. And it is all steel, but we don't have workmen. The people went for Holi, they went for the Eid, now they went for the Bakrid, and all the people are going, now they're going for the West Bengal election. So we have huge problem on hand. We are doing the central secretariat, there also we don't have people. And the government wants everything very fast. Some of the contracts that we are taken from government says, Mr. Modi is pushing, he says, do it in 2 years. But the technology, everything is worse. So we keep telling them, look, we can't do things fast if you don't change the technology. So something they are amenable. So I'll just talk about it. So manpower is not at all there. It's not less. Actually, it is not available. And even on the first and second, I sent all my people to Ranchi just to make sure that they meet with the contractors, meet with the workers and all. And we also have all the numbers. I'll show you how we are doing the digitalization. So all the workers who come to L&T, who get trained, who got a health checkup, everybody's phone number we have. So we send SMS to them. At least about 10 lakh workers, means about 1 million workers we have. We have a database and we keep sending it to them. But still people don't come. So this is a problem we have. Of course, the wastage is very high. And the cost, the costs are very high. So we don't waste 40%, but still there's a lot of wastages in the construction industry. So I will just explain where are we today with respect to automation and the robotics. I'll take it up in 4 phases. First is the precast construction. I think in precast construction, okay, I'll just explain precast modularization, which said steel building modularization, 3D concrete printing. Then the latest one I feel is the PPVC, prefabricated, pre-finished volumetric construction. I think I'm dividing this into 4. In precast, actually, if you see here, the infrastructure has adopted precast to a great extent. Whatever you see in India in metros and all, if you see all the pillars and all, only the cast in situ. The rest, everything is precast. Whether you're in Chennai, you go to Bombay, you go to Delhi, every place precast has been adopted to a great extent in the infrastructure, especially the metro and all. We also adopted the precast in housing and, especially the affordable housing. The people who want to do the elite housing and all, they want something changes and also we can't actually manage it to do with precast. So whatever mass housing we do, we try to do it with precast. Also, a lot of hollow core slabs we are using, especially for the IT parks and the offices and all, we use hollow core slabs and try to make it actually to use the precast to the extent possible. In this precast building, we are also using all parts. In Bombay and all, even in the elite housing, the toilets and all are parts actually. So the parts is consisting of the EWC, the bath, the fittings, everything is there. We just have to erect it. This actually, we tried once with concrete and all, then we continued. Actually, I've been told that in Singapore, all toilets are only made by pots. Maybe I think something that we should tell the country, because in a flat, actually, suppose you do 2,500 apartments, you have 10,000 toilets. To do 10,000 toilets, to do the cladding, do this waterproofing, make sure that it leaks is a big problem. That is the biggest problem that we have actually in a housing. So if it can all be done with parts, so it will become really very easy. So we started it actually, we have in our Powai, we are doing it. Most of the housing, especially Mumbai and all we are doing, and Delhi and all, they're not acceptable. The central secretariat that we are doing, we also talk to the government. Look, it is actually where all the the secretaries of the government will sit. So we had suggested to them that we'll do pots, especially the attached toilets and all will be pots. and they're accepting it. So we also did the testing, and this time we'll do the parts actually with steel. We won't go with concrete because the weights, it's quite heavy. So we said we'll do with parts. This is something that we are there. I think this is something which can be adopted everywhere. We also did this building in 96 days. 96 days, we finished this 12 floors. The construction, we took it only 36 days. Each floor we did in 3 days. And the 12 floors, the finishing, we took 60 days because we had to do a lot of tiling, though parts were there, the other things we had to do, the complete piping and all in the vertical shaft. This is another thing that we did. We did it very fast, Professor. We did it actually in 45 days, this erection. So this was actually a hybrid modular construction where we did actually with, the pipes later on filled with concrete. Actually, this contract was in 2 things. The first 75 days, we had to make everything, all the foundation ready, which was precast, all the slabs, which was also precast, it was ready. We had parts here for the toilets. We had parts here also for the lift. All the lift shaft was parts, everything finished. So we had everything available with us on 75 days. In 45 days, we did this ground plus 6 building. And it's actually 130,000 square feet for DRDO. And on the 45th day, actually, we inaugurated with Mr. Rajnath Singh, the Minister of Defense, actually coming there, and he inaugurated, and he had a call. He had a meeting just to announce that everything is done, all systems are working and all. So this is something that we can adopt, but everything cannot be done probably because this we wanted to test ourselves, yes, whether we can do this thing in 45 days and all. So we were able to do this. So this is something that we did. We're also using robotics, we use robotics for actually the block work and finishing. But to be very frank, we actually tied up with a company, we actually invested money and he made the robots and all, but we're not able to do the block work and all beyond one height. So we're actually doing a lot of tweaking for this so that we can do block work, plastering. So they got various forms. We can just remove and do block work. We can remove and do plastering. We can remove and do painting. So all these things we are developing, but really not in a big way. It is actually more, of an experimental way. But when we don't have workers, I think this we are doing it in Warangal. Actually, we are doing a hospital, which is being done very fast. Oh, this is how the robotics is working. It is a massive one. Maybe it will become slim after some period of time. Okay. This is something which is very favorite. This is a post office that we did in 43 days, actually. This includes the foundation. The real 3D printing, we can do it in 7 to 8 days and all. This is in a place called Alsur in Bangalore, very close to the Alsur post office. And we did everything here, the 3D printing. We also done actually in Cheyar, in Tamil Nadu. They gave us the contract to build a factory. But we went and told them, look, you have got so many buildings, the administrative building, security building, all. It's all ground and ground plus 1. We said, look, we'll do everything with 3D printing. They said, fine. As long as you don't charge us. We said, fine. We'll manage within that cost. So we did all those buildings with 3D printing. And what you see on the right-hand side is we are doing actually this one for the BRO, the Border Road Organization. We're doing a museum and a place to stay. It is ground plus 2. And this building, 36,000 square feet of building, ground plus 2, we are doing with 3D printing. And this is probably will be the largest 3D printing done, they say in world, but definitely in India. This is the largest 3D printing that we are doing now. It will be ready. So we took totally, including design, we had to design this building, we do the foundation. All the foundation here also we did precast. We did precast foundations. We are doing 3D printing. Even in 3D printing, the walls are all 3D printed. All the slabs are precast. So that's how we do it. I also got actually, I took some of the developers and all. This 3D printing can be used for the villas. So I got a contract to do 12 villas in Bangalore by a developer called Prestige. I need to promote him because at least he's agreeing to do that. So when I was doing 3D printing, I called a lot of developers, people from the academics, I call people from IIT and all to show, look, how it can be done and all. So this fellow was very much impressed. I'm doing many jobs for him in Bangalore and Mumbai and all. So he said, okay, this villas you do with 3D printing. So I got it. We did a mock-up. We did the testing and all. Hopefully some of those people will be doing the first 3D villas in India. This is how we are doing the 3D printing. So actually, our finishes are not that great actually, compared, because we had been to the Bauma exhibition in Germany and all. So what we have seen, the finish there is much better. But what they are using it, they usually use cement and sand and all. We actually use cement, sand, and the aggregates also. And we don't use this manufacturer. We manufacture in our batching plant. We have special plants where we manufacture these things, the concrete. So we use the regular concrete because we say that we're proud that we're using the regular concrete. This is the PPVC. I think, PPVC is one where precast, pre-finished volumetric construction. There are many actually hotels in Singapore and all, which are all use PPVC. And, we are talking to IIT Madras to do their hostel block with the PPVC. I'm sure it can be done, but we'll take a lot of time to construct this in a workshop. We'll do it in a very, controlled atmosphere in a workshop. Everything, we'll just only lift it. I think that's what SNS said. I'll do it in 64 days. So probably if my boss says that, then we'll do it at the fastest speed. And the next one is the Mod Pro, where actually we are doing with steel, buildings which is around 350, 400, the primary health center, the clinics and all can all be done with this. We can also put actually, single floor, if you want to do some low cost housing and all can be done with Mod Pro and all. So these are some of the technologies that we are doing in construction. Actually, in construction, it is less, but in other construction related activities like, we have the drone survey. I think we are quite big and we are doing very well. We also call we have the LTI Mindtree, who is also doing the drone survey. And here we use it for data collection, site planning and design, topography, and progress monitoring. And I think this is some of the projects where, we are using all this technology. So we use it in the Mauritius Lightful, the transit systems. We also use in our mega irrigation project. In the high-speed rail also we are doing. Here actually we fly drone every day evening and see what is the progress. We did the Statue of Unity 182 meters on the Narmada River actually. So there it is completely infested with crocodiles. And we did the whole survey with drone. And we were able to actually, all the contours and all we were able to take. There actually we did about in a big, project for water supply project in Madhya Pradesh. It is actually through forests and all. And it was an EPC job for us to code. We completely did a LIDAR survey through helicopters and all. But this is the route that I can go. And so we saved some money. So it's an EPC bit for us. So if I take the route through the jungle and all, which is much easier, much faster, I was able to do it because of the drone survey. I think this is where actually India is doing very well in terms of the drone survey and monitoring the drone survey, the physical progress and all. I think we are doing quite well here. Next come Internet of Things. Here also, I think we are doing pretty well because, many people from US, they come here to us and they're saying that what you're doing in IoT is much better. I'll just tell you, here all our tower cranes and all, everything actually is completely digitally controlled. So every day you can come to our exhibition center and we can see how many cranes are working across our projects, how many times it is rotating, what is the weight it is lifting. All is connected. All our batching plants are connected through IoT. We know in each site sitting in Chennai, how many batching plants are working, how many are idle, what is the stock which is available there. I think all these things are known to us. We are also able to actually put the RFIDs and we are able to see, where is it. Even we put the RFIDs in the precast element, and when we actually do the erection, we know that this precast is erected. So we are quite big in this. So now L&T Infotech and Mindtree, LTI Mindtree it is called now. So they do this thing. This is BIM and 4D and 5D. L&T started the first BIM, in the Delhi International Airport in 2008-9 when we started. The whole thing, the design was done through BIM. From that day, all our design build jobs, we use BIM. And today we are using BIM in IIT Roorkee. So what we have done is that, the whole thing, the billing also is in BIM. So we discussed actually with, the CPWD guys and told them that, look, we need to do it. We have to do something different in this project. So they also agreed. So everything, the project, the progress, everything is seen through BIM. And all our projects we through BIM. What we are also doing is, like we actually bought a scanner now in our central secretariat project. You just put the scanner, it scans the whole surface, and we're able to see what are the undulations. Suppose I need to do the cladding. I need to decide, what is the thickness. Earlier we used to do some survey, put some thickness mortars, spread a thread and all. But now what we are doing is just, put this scanner. Within minutes you have got, then you can say, okay, what is the thickness? How do we do this and all? So it has made our lives very, very easy. This is another thing that we are doing, the virtual reality. Most of our training for the workmen, the safety for training for the workmen is done through virtual reality. We also have the customized training modules, immersive experiences, all that. We actually have a safety school. One here in Chennai, in Kanchipuram, one in Baroda we have. It is actually an experiential center where you can go and see what happens when you fall, how do you fall, everything it is being learned. We also have the VR there and all our programs in various languages of India. So before we take the workmen to our sites and all, we send them, they know that how it is there. You actually feel, suppose I fall, it's almost like, you can just imagine that you're falling and all. So we are trying to make sure that, the most of the workmen are safe. See, we are also able to do the predictive analysis we do actually with safety. So we are able to just say that, which are the job sites and each job site, what is, where it is prone, like, what is one job site is prone to actually things falling from, height, somewhere, the electrical circuits, they are the problem. So there are actually, another thing is actually the excavation, during excavation we do, and also we do the risk profiling of similar job and all, like what professor was saying, we already do that. So we do the risk profiling for each job, and then we say that, okay, in this job, we need to focus on this. So what happens to the project director, the project leaders there, they know what needs to be done. I think we are already doing this. Next is the material tracking, as I told, for the precast panels, structures, steel members, all these things we're able to do. We're able to put the barcode. And, we got the Statue of Unity, the bronze panels from China. So we had all the RFIDs. So we're able to actually assemble things and then update it through the BIM. The next one is called, we got an app called Visa, actually, for the workmen. So here what we do is, we have the database of all the workmen, and we know when we onboard them, we capture their attendance, and when do they come, how do they go, what are the periods when people work and people don't go, and also, like, we also do this health checkup and all. So somebody is good, somebody is bad. This fellow can work at height, because not everybody can work at height. At ground level and all, people can work, but when it goes height, it's not possible. So that is something that we do. I think we have AI. I think AI is learning. So similarly, all of us are also learning. This is what I think will be the future one day. This drone erection, actually, it is also happening today in many of the far off places. If you see, the transmission towers and all where people cannot go, it's all being done through drone erection. It's happening even in India, and we have done it. And, many other companies in India have done, but probably you have to do it in a project where we just send materials to robotics, and then we just make sure all erection is done to the drones and all. Very little physical interference. I think this is what we are thinking, because we simply don't have people. And as Professor and Benny rightly said, this is the most hazardous industry. And nobody wants to come here because, we are the most populated country in the world at more than 1.4 billion, but we are not getting people. And the productivity is so bad. And actually, we started using the form work called DOCA form work, back in the 80s we started and all. And that day when our productivity is around, actually, for a form work guy, 4 square meters per person per day. Today it is 1 to 1.5 square meters. That is the kind of skill levels we have. The skill levels are extremely bad. It is not at all good. We have training centers and also people come there, but nobody wants to come. Most of the people want to work in AC/PC, we call it. So sitting in an AC atmosphere with a PC. This is the most dangerous thing. Why should people go work in the sun and all? But it's also the beauty, you construct something and, we see every day these things coming up. All the buildings that we see. We are done, we have been fortunate enough to done all the airports in the country, most of the big airports, the Delhi, the Hyderabad, Bangalore, and now the Chennai. So we are doing it. We did the Statue of Unity. We're doing the Shankara statue. We are doing the Ayodhya, the Ram Mandir and all that. And every day we're seeing, and we are the only ones who are constructing this and we're able to see. And I also want to say that, there was a meeting yesterday, the Prime Minister addressed, most of his cabinet members, other industrialists. He says he wants to make India by 2047 a developed country. You all see, how much more that we can do for the infrastructure, the housing, and for the people. So there is so much to be done. So we took the 3,000 DTs. I've been telling them that, look, at least in your lifetime, you can see that, India will become a developed country. 2047 is not far off. It's another 24 years. Okay. So with this is what we say in L&T. Logic will take to you from A and B. And I think imagination will take us everywhere. Okay. Thank you very much. I have my colleague also. I think he'll get into a little bit more depth because I've been driving. I also want to tell somebody is the industrialist. We started actually strategic plan, how to do fast and also. Then we started a business unit called B&F Fast. And Professor, we do all the projects here in less than 1 year. Then only it will be called B&F Fast. This is where we are doing the 3D printing, the PPVC, all are being done by this vertical. Actually, under my guidance, they are working. So we are sure that with so many people, so many things happening in Chennai and all, I think we'll really drive this business. Thank you very much.
All right. So good morning, everyone. This is Amit. I think MESF ended it with Imagineering, and that's where that L&T's DNA starts, right? We call it Imagineering. It's a combination of imagination and engineering. So I come from the B&F vertical. You will see the presentation also is fairly influenced with mostly buildings and factories. And what I am going to do is probably go in little more a bit detail. It will be still rushed. We are not going to go in very great details, but you will at least get the flavor of whatever MES sir just told about the things that we are doing in recent times in terms of technology, in terms of the digital space. And if I have to list out some of the largest and tallest, right? L&T, we keep telling largest and tallest. This probably comes the first, Shri Narendra Modi Mathura Stadium. We are doing the high-speed rail. This is, of course, not part of our vertical, but again, mega, right? This girder that you see is about 40 meters long. It weighs 1,000 tons. And the fun part is the team is not excited about the girder, but the team is excited about the straddle carrier that they built in-house to carry those girders, right? The automation, the precasting is a norm, but the automation or the mechanization that what we are trying to push through is evident everywhere. One of the any project you pick up, especially in recent times, and you will start seeing that we are trying to do things very differently. Of course, in the commercial space also, the T2 airport, we are now building the Navi Mumbai International Airport. Statue of Unity, you cannot go forward without that project in the list. We do a lot of work in residential. If you come to Mumbai, probably top 4 tallest buildings are done by L&T. The one that you see in the third one from the left now, Minerva, is the tallest building as of today that we have constructed in that space. So when I go into the details now, I think, like I said, I'm going to rush through the project specific details, but there are 3 or 4 slides what we would like to build on in line with this conference theme today. And where we feel now last 15 years or last 20 years and where the company is moving. If anyone asks me what is the construction mantra, the answer probably from everybody in the team would be, one is mechanization or the automation or bringing in the technology. And then again, last 5-6 years, it has been the other side is digitalization. Right? These 2 things are encoded in our DNA. In every project, you will keep seeing that. And what closes the loop is the innovation and efficiency behind it. So then it keeps going in that circle, right? Your mechanization is bringing an efficiency. That efficiency is tapped by the digitalization efforts. We collect the data, we analyze the data, then we feed into saying what we need to innovate further, and that goes into a newer technology, and then the circle keeps going. How it actually reflects in terms of a system. If you take an example of buildings, for example. So this is what we feel where the buildings industry is going probably next 10 years based on our experience of last 10 years. And it has been drawn to that S curve for a reason. Imagine that the system is going from a low-rise building to mid-rise and then the high-rise. And if I get into the math, if you start taking the derivative of this curve, you are going to see the derivative will reflect the rate of change in the technology in terms of those systems. So you take a G+4 low-rise building, not great change. We are doing it well. Maybe we have to push it a little further. If you go into 10 to 30, 35 stories, lot of changes are coming the way we are building these buildings. Again, if you go to the high-rise system, maybe 50-story tall, you get into whatever we are doing is probably fine. We are already doing that. We'll start seeing some changes in moderate systems. But the crux will always be some sort of hybrid system. Not one technology will rule the construction space. And the undeniable thing would be prefab or off-site manufacturing, right? Whatever challenges we discuss now, not having the workmen and all, we will have to take that construction off-site and then build at that efficiency. So this is actually one of the finest example of that off-site construction. The Mission 45 for DRDO, what we looked at, whatever building you're seeing was built in 45 days. And this is kind of a imagination or the time-lapse video of how that building was done. Like excellence in planning. Everything was prepared, bed ready, hybrid system, seal system, precast slabs. We have false floors, we have glass facade, whatever that you can imagine to build a building was planned. And I think we have Madhu here who has done the method planning and all to get this building through. But exactly as planned, right? That's where that assured delivery, what we follow now, that we will tell you something, we will try to deliver the same thing in what's promised. If I get into the residential side, now we mentioned about that Mission 96, but the whole precast was feasible there because of that large volume, right? The entire tender was about 150 lakh square foot of built up area. And that's not the fun. The key thing was, it was to be delivered in 42 months. That's the kind of projects we are looking forward in that space where the precast was taken up. And if you look at the math again, it's about 8 flats per day. That's how the delivery schedule is. This is where we took that call that conventional systems cannot be used to build this project. The entire tender was at that time taken using precast construction. And if you see that one corner tower, then later we say what the technology can do best, what we can showcase with the technology, not per your plan, but the best of the best. That Mission 96 was taken, where we built one tower, 12-story tall, in just 36 days. That's where the technology, the mechanization is standing, right? 3-day slab cycle, which is what we have been pushing for last 5-6 years in that space, and that was achieved quickly. Again, this is a real-time time-lapse video, right? It was slab itself in 3 days. Like usually we do 6 days, 7 days, then pick up and go with that thing. But exactly as planned, hour by hour planning, and delivered in 10 days. The water tanks also were delivered in 7 days. Total precast system. We had water in those tanks in 7 days. Finished as planned. Then we come to this 3D space, right? Why we are doing 3D, and a lot of times the question will come, okay, why 3D? Yes, it is a speed game, but more than speed, it's a productivity game, right? If I say a job where I need 100 people in conventional construction, I go to precast, I'll need 30 people. I go to 3D and probably we can handle that in 5 or 6 or 10 people and then get the job done. And this is again one more time-lapse video for that post office building, right? This was one of the first jobs, but like I said, 43 days, and the actual printing was done in about 12 to 15 days itself, exactly as planned. Again and again, everywhere you will see that timely delivery is what the motto is, what the focus is. We will promise you something and we will deliver in that time. This was one of the, again, unique job where the exterior, we decided to keep it with that 3D technology and not finish it or plaster it. Because plastering it, okay, we are used to seeing that, But then that kind of takes the advantage of what you're building in terms of speed using 3D. So you kind of have to learn or live with the technology and not try to force whatever that you've seen for past 30 years into the technology and then take the efficiency out of it. So with that experience, now we took the next step where we have our SLN here who has been driving the 3D, and we took this job, almost 36,000 square foot of built up area. And you will see peculiarly in that job, again, we are trying to take the advantage of the technology. You will see the buildings have the curves. You see the middle one, I think Rajkumar Murli is here, you can interact with him, but he sliced the building, and the way it is designed now with the shifts and all, it's a nightmare to do that in conventional formwork, right? We had some areas where we said we will do that beams and all. The site team is coming back and saying that I don't want to do conventional. I don't want to go ahead with the system itself. And this is actually the real life picture. This was taken 10 days ago, but between those 10 days now, we probably build another floor. We are hitting that 6 or 7 day cycle and continuing, right? Then next we discuss about the PPVC. Yes, that will be even faster. The 3 day cycle that I mentioned in precast, if I do the PPVC precast, we probably are looking at a 1 day cycle, but we do a lot of work offsite, right? Whatever 10 or 12 ton elements I'm lifting, they will become 30, 35 ton elements finished in. That's where that PPVC will probably start shifting to steel PPVC, which is much lighter and probably suitable for the commercial buildings. So to gear up for that PPVC, this work was done in probably 18, 19 time frame. We proposed that, then we said the heavy elements. So we'll start slow. And this is those Powai pots, what Mia sir was mentioning. Entire toilet bathroom unit was finished at the factory level, including all MEP fixing, everything, waterproofing, water testing, ponding. And then that pod was directly lifted off from the factory, placed on the actual live construction floor. And then the building was built around it. But the efficiency or the beauty of it is not a single workman entered that, except that outside door, because it was right around the construction, that was replaced. But what you see in the pictures, everything was finished at the factory level. The same was extended in this DRDO building for the commercial larger ones. So these are again 30 tons a pod, but what you see again, finishing everything, it is done at the site level, pods brought at the factory and then installed. So we talked about the building structures, building systems. And then the last component will usually become is the facade system. So that facade is also, we are taking up next steps. A lot of things are in the discussions now where you can do the solar panels, actually start harnessing the energy. The one building that you see right hand bottom side is our corporate building in Mumbai, which has the lights and everything in place, which we are taking that facade also to the next level. So with that, now we quickly come to the second part, right? The digitalization, mechanization. Yes, we have been doing that. And of course, we have been doing the mechanization for a much longer time. Digitalization is new, maybe recent, whatever last 6-7 years we've been trying. But why do we need digitalization in construction, right? And most times the answer is BIM drawing. But what we have done is probably taken the 6-7 steps beyond that. We are not using just for the BIM. The BIM, of course, becomes the central model around it. But what we are looking at is the interaction of various agencies in that construction project. Not even internal, lot of times the external agencies, even the client can look at it. Clients is reviewing the BIM models, approving the finishes, right? For that Sidco building, which came right in the middle of the COVID, our architectural finishes, the first finishes were approved on a BIM model and a VR set at that time because they couldn't visit the site. So we visited their offices and showed that, and it was approved in that. So in that line, we have been pushing this digitalization, and you will see several activities across L&T, right? That true big data sense we will get when we start looking at all our equipments, all our connectivity, lot of numbers. But what it actually translates the whole thing into is we're trying to push it in entire construction ecosystem, not just one area in the drawings or not just the P&M. And these various aspects are kind of becoming a way of life. And that's where we call it the digital ways in L&T, right? So this is one actually simulation done pre-tender. So this is not only for the client, but even for our team, for a stadium, you get to see in real life how we will set up the project. The project director is going to have that whole view and his experience that he can put in quickly saying, oh, this doesn't work, this works. Instead of a 2D drawing, we are kind of walking it through saying, okay, these are the each steps, each activities, including the people walking, the walkways, how they will get in and get out of the sites, right? This is another example for the point cloud. I think Day before yesterday, you have a lot of debates on that. But for this Delhi stadium, we have used it and it works beautifully, right? Instead of just looking at a 2D picture, you are now getting a 3D real life model directly scanned from that drone. The BIM, I think BIM, we said we have been using in since 2008, but we have probably now taken it to the highest level. That CIDCO project that you saw, entire BIM model had, including the smallest number 6 millimeter tie also model. So if you see the right hand side picture, that's the each element BIM model, and we have generated the actual 2D drawings through that BIM model and without doing any significant work on it. And what you see on the left hand top corner is the actual production drawing directly imported from that BIM model. So you change anything, you actually are going to get that. But that's not the end, right? Even the molds, our CMPC teams, they define the molds, design the molds using that same BIM model. So I don't have to worry about that repeated information and then the issues that come because of the lack of information. Then what next on that BIM model is we built our own app to track it. I think what now it has become a material tracking app for the entire our BNF, but it started for the precast where the idea was you have each element, you track it through the entire life cycle, right? When that element was cast, with what grade concrete, who checked it, who signed the checklist, how long it was stored in the yard, when it was shipped to the site, entire life history is being tracked. And that's a record keeping, but it is all real time. Like usually we have been doing that in an Excel spreadsheet, but here we are looking at the moment the scan is done at 8 o'clock in the night, that shows on the portal and it adds, okay, saying these many elements are there, these many are on the truck, these many are site stored. It gives me a real time picture of actually how many elements or how many towers are also being built, right? Then we took that next step to move it to the digital twin. So same model was taken to the Ram Janmabhoomi temple, where we are now actually showing that status on the model. So the client gets to see the stone of column F2, each has 7 or 8 elements, whether they're in quarry, whether they're in storage, and whether they have actually installed. And then from that RGB, again, we brought it back for the actual twin, where now our towers, we are monitoring, saying today this was planned, actually how much was done, and real time for that mission 96, all 36 floors were tracked using that twin model. Another thing for, again, efficiency, we are tracking the concrete strength development in real time. So there are actually meters put in there, and that gives me the actual strength so that I can plan the next activity immediately. Usually we used to estimate, we will wait 4 or 5 hours. Here now that strength is being told to us real time so that I can save those 3 or 4 hours and then take it further. And then I'm just at the fag end, how we are doing the actual now the monitoring and review part of it using the AR, VR, whatever that we have been seeing on the YouTubes now. We've actually last 2-3 years, Kishore is from our digital team is here, you can interact with him. But we have started using that, right? What used to be fascinating a movie scene, we are looking at it, throwing our tablets and seeing whether whatever has to be done or not. Right now, it is probably being used for monitoring for the status review, but quickly this is going to be a good part of our day-to-day construction activity, right? So walking with the tablet is a challenge. So we said we will use the HoloLens and you can just roam around. You get used to that. It takes some good bit of getting used to it, but this kind of tools, this kind of efficiencies is going to help us build faster, build accurately. I think Professor Kamakutti was also saying that speed and accuracy. So this is where we do the first thing right and don't keep repeating items, right? The laser scanner. So that follows with that HoloLens combination, the laser scanner. So whatever the as-built service, which usually takes 4 or 5 days, by the time it's flagged, it's too late. This is now becoming instant where I quickly do the scan. I'll check the levels. In precast now, next week, we are doing a demo where even the number 12 or number 16 dowels will be scanned saying if they are at the correct location or not, which usually it takes a long time to survey each dowel to make sure those are right or not. So that each facet, we have been doing that. You come to PNM, I think we have our Ravindran and Vishal Verma here who heads the PNM. But see the beauty of it, how in every facet we are trying to adopt it, right? You take our DG sets. Now these are usually sized based on our experience. There is a factor, so they are usually oversized. But what we are doing now, each DG have their own smart meters and they are looking at it, how much is the real consumption. So first 20-25 days, they will monitor and then quickly change if required. And the table, if you go, we will share it later. This is pre-digital and post-digital. There is drastic drop in that consumption because of this smart monitoring. More than 50% we are actually adopting and using that real-time data. Same thing for our fuel, right? We talked about wastages. Fuel becomes one of the biggest area of interest where you can save. And all our fuel dispensing systems now, the new one that are in the pilot mode, they are having RFIDs. So they will link with the actual equipment. So even if I have a third-party vendor, unless our site puts in the system that RFID matches, that system will not dispense fuel to that guy. It has to be in the record. If you feel that he has done his work and billing is done remotely, they can switch it off. So if he comes the next day trying to get the fuel, he may not be able to get the fuel, and that's how we will be saving on the fuel. This quickly is the batching plan, right? What MES sir was saying, entire history, entire dashboards are available, how our batching plants are doing. Same thing we have extended to the safety, what that safety risk metrics, right? Each data is there. Our own data that we are trying to not only collect it now, but analyze it and predict it, saying similar patterns are there. So those are highlighted in the review meetings. The CPMs or the project directors can quickly take the action saying, I don't see something is wrong. Maybe better resources are needed, better team is needed, or somebody has to visit and monitor and check it, right? All of your workman trainings also, these guys like it, right? They get to see so many things. Lot of time the feedbacks is, ये तो ऐसा मैंने देखा ही नहीं था, पता ही नहीं था, पर 3D में अच्छा दिखा करके. So that will come. Now how, and this is the last slide, how this will all tie, right? We are all talking about sustainability. Yesterday also was the first session in sustainability. And of course, L&T has been doing our part. We have our water neutrality goal. We have our carbon neutrality goal. But in terms of today's theme and this automation and digital, I think one of the biggest contributor, what Professor Benny said, is wastage. And all these tools are probably help the greatest to reduce that wastage and then play our part in terms of sustainability or in terms of bringing sustainable construction. And how its various facets, again, like in terms of your drawings, your delivery, the time is saved. In terms of your planning, you're doing accurate planning. In terms of your actual material wastage and all, what we are tracking in terms of fuel, in terms of your power, overall delivery rates, overall processes. And that's how we will probably contribute towards that sustainability. And with that, I think I would probably like to conclude. Yesterday, we discussed about Iron Man. And this is a 2008 movie, I think Eagle Eye. I don't know if mostly people would have seen, but if not, I think it was pretty ahead of its time. But that AI is what we are looking at it, right? That movie had this ARIA, right? That is autonomous reconciliation, intelligence, integration analyst. And if you look at it, all these terms, this is exactly what a project size now is looking at, is something autonomous, something that is actually looking at it and reconciling data. It's not just the data collection. You have to actually intelligently apply that data and then integrate it. So do we really need that ARIA? I think, yes, that's the imagination you talked about, that it will take us everywhere. So that burden is probably on this academic community now, whether we can get that ARIA into construction and automate everything so that we can build efficiently. Thank you very much. Appreciate it.